Hi, welcome back to the book club. And so this time we're actually still in this interstellar travel book because they do a great job talking about the sort of the human portion of spaceflight. The other book does a little bit too, but this is kind of more a deeper version where I wanted to really get into. And so ultimately the challenge, last episode we talked about propulsion, how are you going to move around in space to achieve all these economies? And this is now going to be talking about, oh, you want humans in space. Again, back to the survey says most people in the industry think it'll be 80%. Survey says robotics, and you're going to find out why here today, okay? Yeah, it is hard on humans. Okay, so let's just start writing down the hazards to the humans, okay? So from a hazard point of view, what all are we talking about? Okay, well, first one is just gravity, and no gravity is super hard on the humans, okay? And it affects both your sort of central nervous system, CNS, and you can also have what is it called? Space-associated neuroocular syndrome. Space-associated neuroocular syndrome. Okay, jacking with your eyeballs. Okay, so super hard just at the beginning. Okay, we'll actually talk about a few more things here in a second. There's the isolation. Okay, in confinement. Humans, we are social creatures, 100% social creatures. Again, if you try to do an analogy back to the explorers of, say, Antarctica and things like that, like there were crews of 20 or 30. The idea that we're doing crews of like 2 or 3 or 5 or 6 or 7 to think about going to Mars, like, ooh, I don't know about that. Now, certainly at the space station, we've had crews, small crews, but really, I mean, they're only there for a little while. Have tons of communications towards Earth. Once you start getting in that time lag going towards Mars, and it's 10 minutes, 20 minutes, 3 minutes, you're basically sending postcards at that point. It's not quite the same as sort of this live interaction. Okay, you think back to COVID when we're all stuck in our houses. Zoom and things like that really helped. If all you were doing is just writing letters, it'd be really pretty bad. Okay. Another issue is distance. Okay, if you start getting out beyond where the Earth can support you, so maybe a moon base is okay, but you start talking about Mars and things like that, just resupply becomes really challenging. Again, as well as communication. So communication is from two things, not just from the isolation point of view, but if you have an issue and it's sort of 20 minutes back and forth with these postcard type of messages, that gets really hard. So your crew is going to have to turn into the ability to be able to handle most emergencies. I'm in the Navy Reserve, and so like when I think about this from a naval perspective, yeah, ships have the ability to do some repair and maintenance on board. We actually lost some of that capability because we kind of kept pushing it off. But it always requires, these ships, right, Navy ships always require some sort of tune-up back at a shipyard. And sometimes they're small tune-ups and other times they're larger tune-ups, but it becomes really a big deal. And then resupply. Same thing, putting my naval hat on. Ships are always out there getting resupplied with oil, getting resupplied with fuel, things like that. So to carry enough stuff to sort of handle all your normal operations, food, power, water, things like that. Now you have to add on top of that what could potentially go wrong. So what extra pumps are you going to carry? What extra boards are you going to carry? What extra medical supplies are you going to carry? So this really quickly becomes quite a big challenge from just a hazard point of view. Okay, it's a hostile environment, right? So it's your whole thing is closed, and so you got to manage things like the CO2. Okay, you got to manage off-gassing, right? If any material you bring on board, a lot of times it's going to off-gas. So how do you get rid of that? You can't just open up the windows, right? Kind of air out the system. And then what happens if any of these things get contaminated? Okay, well, there's your water supply, your food supply. What's your ability to handle some sort of off-nominal event? So it really starts adding up, okay? And then really, when we kind of talk through this, there's a kind of called rules of threes, okay? And we'll get into it here in a second. Actually, I'm going to do the rules of threes next time. Let's just carry on what we're doing. from a timeline point of view, just to talk about what are astronauts actually end up facing. So from a timeline point of view, basically 2/3 of them throw up, okay, vomit. It takes like 2 to 3 days for their stomach to settle down into this whole zero gravity thing. You're welcome to go ask any astronaut. So so again, one of the things why at Venus we're talking about high-speed flight from point to point is just because I can't imagine you would actually want to go suborbital to move people around. Given this, like you're just going to vomit, and how long does it take to kind of recover your lunch? Okay. Then upon landing, let's just say this: when you're landing, basically you're a wet noodle. Well, that's the scientific term. Okay. So astronauts, when they come back, even if they've been doing lots of exercise on a space station, they enter back onto gravity. They're a wet noodle. They can't do much. In fact, it takes about plus 2 weeks for them to pass effectively a DUI, for them to pass a DUI test, like kind of where you cross your arms and walk one front step at a time. There's some good videos out there of astronauts just like doing this, and they've been back on Earth for 10 days. Okay. And those astronauts like weren't in space for forever. These were like spatial astronauts where they were just in space for like 2 weeks. Okay, so it can be pretty rough. All right. There's mood alterations. There's they call it space fog, where your brain just feels foggy. Okay, so all of these things are there. Some of the things that's been happening also from your muscular skeletal system. Okay. Take a look at this picture. Okay. Puffy head, bird legs. So all your blood is sort of going up into your head. It's going away from your legs. And it's just really brutal on the system. Okay. And so you have your muscle strength is just really drastically dropping. Now, there's some things that we can do. So that they do some training, and we're actually learning a lot about protein. In fact, we're learning that humans, we should really be taking a lot of protein. Like I'm starting to have to take a bunch of protein shakes just to kind of keep that protein level up. But there's some evidence that if our astronauts really kind of take a bunch of protein, they'll be okay. Now, protein tends to be a little heavier and a little more expensive to get in space, but hopefully that might help on the muscle strength sort of things. Okay, but on bone density, they're basically seeing it never returns. Okay, so astronauts who've gone up and had some bone density drops, it doesn't come back. Okay, so just brutal, you know. Cardiovascular, that's also some of this puffy leg, so cardiovascular. So puffy head, you hear. There's immune system issues, namely, you're not exposed to anything, and so your immune system basically goes into a relaxed state. So when you land back on Earth, it's pretty hard. And of course, you have the central nervous system stuff we already sort of mentioned, CNS. Okay, so there's this really large list of things that really go wrong. Now, one of the ways, at least I look at this, I could take a look at all of this stuff and say, okay, medical research is coming, things like that. However, I could also look at this and basically say, if we just have rotational gravity, if we just build larger ships, like you've seen in The Martian, with a spinning gravitational ring, a ton of this goes away. Okay, a ton of this goes away. And so, if you're actually talking about humans in space, on space stations, long distance missions to Mars, honestly, I don't see how quickly the path towards solving all of these things from a medical field point of view versus just engineering our way out of it. Now, it's more mass we have to send down range. I get it, but honestly, just a centrifugal system really helps kind of take the edge off of this. Okay. Other things is this is sort of the picture of, it's kind of grainy. I'll find a better picture for you next time, because actually the next episode I'm going to dig into this. So I'll just kind of turn it off here. But it's the environmental system. So environmental control life support system. So I'm going to do an entire episode on this, so stay tuned. But this is where you have to have air, and that's both at the right temperature and the right pressure. You got to scrub the CO2. You got to match the humidity. Okay, and so there's a whole process here that's pretty fascinating. So I'm going to do a whole episode on that. Okay, but you also have to catch within Eclipse. I'll add it to the side here. So any kind of dust, you got to handle process that. Your lint coming off of your clothes, things like that. And then, honestly, some other ones from a human point of view, I'll add them down here. So we already mentioned psychological somewhere over here. Where was it? Yeah, isolation, psychological. So I'm not going to write that down again. There's an issue of reproduction. Okay. Depending on how long you're sending people out there, this is going to come up. Okay, so what is it going to look like for us to do reproduction in space? What is it going to look like to raise kids on Mars? Some good sci-fi shows have already kind of examined some of that. That's going to be a big one. Okay, and then also I'll add down here just radiation in general. And I think I have a good picture here of, yeah, this is a good picture of the Earth. So the Earth, we have a magnetic field, and so you have all of this solar energetic particles coming out and then being blocked by our magnetic field. So it's really quite good. Now, some of the cosmic rays do come through it. So you're not going to be able to avoid a ton of cosmic rays out there. But, once you leave sort of the protection of the Earth, you're going to then need to have a system whenever we detect solar events to be able to get into a shielded room and things like that. And so that's it's a big deal. All right. Now, some of the things that we know is going to help. So I'll sort of finish with up here things that we know to help. Okay? And I already mentioned a couple. But if we're really going to go do this, if we're really going to go put people into space, again, this is almost the reason why you can see maybe it's robots. But what helps? Okay, one is nutrition. We are absolutely finding that nutrition makes a massive difference. That's true here on Earth with humans. Okay, there's a fascinating bear study where they were feeding bears, like the Kenneth National Park was just some of our excess food, and they are actually able to track the bears' longevity, and these bears did not last nearly as long as bears that are out in the wild just eating berries. So it's a little bit of like, gosh golly, like what are we doing to ourselves? So ton of field and nutrition that's going on, and including, like I mentioned, sort of for sure we're seeing value add in protein. In fact, there's an experiment where they took a healthy person, put them in a boot, in a cast for 6 weeks, but just really kept up the protein, and then they had no muscle atrophy. So again, we're learning just a ton of stuff about nutrition, and so that will absolutely help. Exercise, this is for sure a big deal. They do it on the space station now. It helps. And the third one, I've already mentioned, this is producing artificial gravity. And so until we've discovered how to do it with like physics or something like that, this is basically a big spinning ring. Again, when I think about space stations or humans really out there for a long time, to me, this is the obvious thing to just take away all of the stuff from a problem point of view. And honestly, when you start really thinking about self-sufficient, so the space station is not self-sufficient, we keep resupplying it. As soon as you start having something that's a little bit further away that you need a lot more self-sufficient, like the mass of that system is going to start getting big anyways. And so, having a habitat ring that rotates is not going to be a big jump. Okay. And the last one here is touch. Honestly, like humans need touch. Humans, it's the some of that's that psychological isolation, things like that. And so for some of us, especially kind of the Western world, we're a little more touch averse. You go more to Europe, and it's like kiss on the cheek and give you a big hug kind of stuff. Touch is, honestly, they're finding a lot of stuff about touch. So just having a crew that are giving each other hugs or what have you. Some of this could actually extend into why some studies have shown, like sending married couples to Mars would actually be really useful because they're clearly touching, and there's some stability there as well. So that's a kind of a big one. And then sort of underneath this, so maybe I'll a little slide over here. We will talk about this here in probably in the final episode, some cryo. So if you're doing a long journey, there are some research going into kind of cryogenic suspension. There are animals here on Earth that hibernate. There's some evidence that humans can actually kick into that hibernation mode. So we'll talk about that. That's pretty damn interesting. Stem cells. That's kind of come in and out of vogue, but honestly, stem cells have one of the biggest possibilities to repair humans, right? These are the stem cells. So there's a lot of opportunity there. And then I'll sort of do the genetic mods down here. So with CRISPR, we actually have a lot of idea of what actually the genome is happening. And so we can start having the ability to modify the human gene. There's some good sci-fi stories. Red Rising is one of them. That's a great story if you haven't read it, but they actually kind of take into this where it's like, we've actually modified humans on a couple different branches, some for spaceflight, some for like survival on Mars, some for like, it's actually pretty interesting. The great story, by the way. But this is a thing that we could do. Now, there's a lot of ethical conversations around that for sure, but that might also be one of the things that really help humans survive in space. So I think that's it for this episode. The life support system I find so interesting. So I'm actually going to do a big deeper dive on this one on the next episode to kind of talk through this. There's some really cool things and really cool technologies that are coming along. So I'll kind of cover what the space station is doing and then sort of some next couple things. So we'll see you on that episode.